This video is using halocharms in your naming, which are halogens that are branches. And we're going to see that in with single, double, and or triple bonds. And we are going to refer to this list for how we name that. If we have the element fluorine, which of course the symbol in the problem will be an F, we will use fluoro. Chlorine will be chloro. Bromine will be bromo. Iodine will be iodo. And acetine will be aceto. So if we have a halogen specifically, that's how we're going to list it. Remember, we already know from a previous class and video how to name when the charms are carbons. We use the same carbon prefixes that we use for charms in that video, which is count the number of carbons, use the carbon prefix, and add YL. So, for example, just a quick reminder, if we had one, that would be methyl. If we had two, that would be ethyl. So that's that list of methyl, ethyl, propyl, and that's when you have carbon charms. All right, so of course, the first thing I have to figure out is what is my longest continuous run of the letter C, because that will be what I call the backbone. In this analogy, that would be my bracelet, and the stuff hanging off of it would be charms. So the first thing that we're going to do is we are going to find the longest continuous run of C's. So if I start here, I have 1, 2, 3, 4. And if I went down here, I'm going to tell you 2 reasons not to. 5, 6, 7. I get 7 for my first answer. And if I went 1, 2, 3, 4, 5, 6, 7, 8, that'd be a bigger number. But let's just argue for a second it wasn't a bigger number and I had more carbons down here. You cannot make this turn when you see that there is a charm here. This has to be part of the main chain, because you can't have a charm, something hanging off of it that has something else hanging off of it. So this F has to be attached to the main chain. Now I actually have 2 different equal options. If I went 1, 2, 3, 4, 5, 6, 7, 8, I'd have something's hanging off here. And if I went 1, 2, 3, 4, 5, 6, 7, 8, I'd have something hanging off here. When they're equal, pick whichever way you want. What will happen is whatever you have hanging off of it will actually end up hanging off of it from the exact same carbon chain spot. Okay, so just to remind you, we will need to count to find out who is carbon number 1. If I look and I count this direction, my stuff hanging off will be hanging off at carbon number 1, and I'll have stuff hanging off at carbon number 5. So how will that mathematically play out? That would mean that 1 plus 5 equals 6. This is golf score wins here, people. Golf score wins, meaning lowest number. If I use the red numbers and count the opposite direction, I get stuff hanging off of stuff at 4 and off of 8. Well, 4 and 8 is 12. That's not the winning way. I'm not using the red numbers. I'm using the black numbers. So that's how I am deciding which direction I'm counting in. So once I have decided and I know, then I could start naming the stuff that's hanging off my continuous chain. So I'm using the numbers that are going here from right to left. That means I have this guy hanging off my number 1 spot. Do you remember what he was called? That's new to this video. It is the halogen charms. And so that thing is called the fluorocharm. So that is fluoro, and we have to tell the reader where it's located. And so that's going to be a 1 fluoro. Okay. The next thing that I have is off of number 5. Off of my number 5 carbon, I have 1, 2, 3 letter C's. Remember, if you're counting letter C's, you have to use the prefixes for carbons. So that was meth, eth, prop, bute, and then actually from there, there's no difference. It's penta, hexa, hepta, octa, nona, deca. So only up to number 4 do the carbon words vary. So I want to say 3, so I have prop. But this isn't a main chain, so we tell the reader that it is something hanging off by saying propyl. So I've got a 5 propyl and a 1 fluoro. As this says, the charms are listed in alphabetical order. You will put the number with it. The number lets the reader know where that charm hangs, but you can't put them in the number order. You have to put them in the letter order. So which one comes first? Fluoro comes first. So you have a 1 fluoro, and then you can say you have a 5 propyl, and then I say its last name. Well, this is oct, and these are all single bonds. That one we don't care about. That's a single bond, single bond, single bond, single bond, single bond, single bond, single bond. So I don't have to tell the reader anything about where anything's located because they're all single bonds. And I also only have single bonds, so that means the ending is -ane. Once again, just to refresh your memory from previous class and learning videos, the order is ane, single bond, ene, double bond, and ein is how we say something that has a triple bond. And to me, it's easy because they're in alphabetical order, and that is how I would decide which way to organize that. So the name of this is 1 fluoro, 5 propyl, octane. All right, let's try it again. So first order of business is to find my continuous run of C's. This problem has a slightly different issue. I've got a double bond. And double bonds always have to be on the main chain. So I'll definitely be including this guy. Also, once again, when I make this turn, I see that I have some non-carbon tagglers here, and they have to be on the main chain. So that's why I have to decide to go this direction instead of coming down, even though those are, even I see they're lower numbers, but even if they were a bigger number of Cs, because these CLs have to be on the main chain. Then I have to decide who is carbon number 1 before I even decide any of these other things, because double bonds take precedence in the numbering system. And once you've numbered for the double bond, it stays that numbering for the remainder of the time. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll tell you an easy way that I always decide this is I kind of picture myself a seesaw, and double bonds weigh more than single bonds, and whichever side weighs the most is the front. So I could easily see if I were to stretch this out to one big flat stick, that's this stick right here, that this side would be what I'll call heavier, and therefore number 1. Because it'll either be number 1, remember golf scores win, or that would be happening at number 9. So obviously 1 is lower. Now, once you have numbered for the double bond, it actually makes life a lot easier on you, because now everything that's hanging off already is set for its numbering. So I just have to go around and say, what do I have hanging off? Off of my carbon number 4, I have this 1 carbon charm. How do we say that? 1 carbon is a methyl. Off of number 6, I have one of those new halogen charms. Oops, I almost said halogen there. And it's chloro. Off of number 7 right here, I have 2 charm. I only had 1 here. He was methyl. 2 is ethyl. I use carbon prefixes because I'm counting carbons. And over here on number 9, I have another chloro. Now, whenever we have something that is the same, see, I have a 6 chloro and I have a 9 chloro, we put those together. So I would have a 6, 9 dichloro. Now, where did I pull this di out of my hat? I wasn't counting carbons, so I don't use carbon prefixes to say how many I have. I go back to my Greek prefixes, which of course, if you remember, they were mono, di, tri, and tetra were my numbers 1 through 4. So mono, di, tri, tetra. And so this is a 6,9 dichloro. I don't care about the di part when I'm alphabetizing. So they were going to be who I was going to say first based on the chloro. So remember, I'm putting these in alphabetical order. So I already started doing that. Chloro is going to be first, 6,9 dichloro, followed by a 7 ethyl. These would all go on one word. Followed by a 4 methyl. Then I would say my last name of my continuous run of C's, my chain. And so this is 10, so that's dec. And I have to say double bond, so that's ene. Remember, my choices were ane, ene, or ein. Double bond is ene. And I have to say which is the first carbon that touches that, and that's carbon number 1 touches that. So my answer is a 6,9-dichloro 7-ethyl 4-methyl 1-deckene. I hope this video helps you.